My friends, thanks for joining. So today we are discussing something really cool. So we are going to do a zoom in of the security controls from a technical perspective. So that means a lot, and I need to fly through a lot of content, and I will try to do it without slide, more with diagram, and so commenting in the meantime that I draft something as a diagram. So to remind you, this one is the Infrastructure Security Consultant course. The first chapter, we introduce all layer of infrastructure. The second chapter where we are actually, I zoom in into security control. So we are at lesson number 2, and so we are going to discuss inline and inspection design and how does it work with security control in general. So to do that, let's move forward here. I will reduce my face size. Anyway, I'm not a nice fella, so doesn't matter. So let me put this one here like a small stamp, and we are done. So we have two endpoint communicating A and B. Okay. So consider that A is the client and B is the load balancer, is the firewall, is whatever you want. So we go through the layer. There is a network connectivity if we strip down quite easily, and we move up to the application level. So there a security control, let's think that this one is a load balancer, and here we place a nice firewall, okay? The typical stuff. So now we are having something to analyze. What is happening? This one, first of all, is a security control that is defined inline. What does it mean? It cut the wire. This one, from a technical perspective, means that if this one goes down, there is no connectivity. So there are security controls that are designed to be fail to wire. So it means that there is an interface, a physical network interface, that in case there is no power, is having a spring that let to bypass and short circuit that, letting the traffic to go through, even if a device is dead. So generally, what is happening, for example, in firewall, you can have an active passive like that. They do have here a router that is having as a default gateway a VRP. So VRP is the address that is shared, because each time there is a failover, obviously also at MAC address would change the MAC address, it would create a problem. It's not perfect, but you understood. So client is connecting through internet, the router is going and is the BGP router is sending to the VRP address that is shared between active and passive. So these two security controls need to be stateful, because if there was already an established connection and one goes down, the two need to share information. That is happening through a link between the two that is called HA link. Okay. This one is how does it work network-wise, whatever device is an active passive in somehow. So there is a continuous HA interface and continuous sharing of a session. If one goes out, the other can cope with that, still keeping in track what it was. Another way is to have something like a cluster of firewalls. And so here you have just a one unique IP, there is no VRP, and inside part of this cluster you can have multiple firewall, okay? So it doesn't change the concept. There is still a sharing of a session. It can happen in multiple ways, depends on the product, but that is how it does work. So right now we need to think on the security control at which layer is. So you always remember that firewall can be at layer 3, layer 4 of the OSI layer, or can be at layer 7. If it's at layer 7, it's supposed to be capable to establish and verify the traffic. You need to consider where the SSL get established, because if SSL get established here within this layer, you are having a problem because obviously your security control can't see that. We are still an inline design. If something goes down, you rely on the clustering, on the high availability, or whatever mechanism it does give you the way to have a control. If your control is having a fail to wire, like the one that I mentioned, where actually the traffic can pass through, you can have a security control that can have a temporary status where it doesn't act. So in your analysis from an infrastructure security, you need to be aware also of this race time condition where you can have the service down, traffic goes through, and there is no controls. There is the balance between availability and security. It's a long conversation, but you could find in your experience some of this control failing, and it's important for you to know when they failed and have some other controls in place as a mitigation, or anyway have a lot of thinking about it. Now that we discuss this situation, we want to see what is happening when the control is offline. So let's put it for example that you do have an offline IPS, okay? So here you can think of on your left the client, connect to the router, send it over to a load balancer, let's put it in this way, and the load balancer is going to the backend pool. You can have a pool with multiple server behind. Anyway, you understood. Sorry if it's not perfect. This diagram is just to support my talk, nothing more. So right now what is happening is your traffic at SSL get terminated here on the load balancer, okay? So client is having an SSL and shake between here and the load balancer, and there is another SSL and shake that is taking place behind if it's not an SSL offload. And so that means that there are two SSL and shake. The load balancer that is this layer is the only one capable to see the traffic in clear, because there is an SSL here, load balancer is having the clear traffic and re-encrypt on another interface, okay? Let's think that you are enabling a mirroring of a traffic. You are sending over to an IPS that is seated on the side, IDS. The difference between IPS and IDS is actually this design. At the time that is here, built in a firewall, in a load balancer, whatever it is in line and is capable to stop the package. At the time that is here is from IPS, that is a prevention, and so need to be capable to cut the wire and stop the communication, is moving on a side and is becoming a detection. So what does it mean? That obviously the package is traveling from the client to the backend. A violation is recorded here. You have only visibility. So it's extremely important that you have clear in mind this consideration, because when you see an infrastructure, you need to be capable to analyze what is happening, what is the design, and what it does mean in terms of controls. So there are security controls that are giving you visibility but are not giving you capability to stop something. For example, here we have a load balancer mirroring the traffic going to an IDS. IDS shout, but the package is already passed. And so the exploitation can't have been taking place. So, quick summary. You have a design that is inline, cutting the wire. You need to think what is capable to see. Is capable, for example, to terminate an SSL and shake and see the traffic or not. Because the fact that you park something in the middle doesn't mean that actually is taking any action on it. Depends on the configuration, depends on a plethora of factors. So first distinguish, is in line or is not in line? Is cutting the wire is becoming a point of failure or not? Is having a fail to wire and the security control can be bypassed or not? There is any connectivity that an attacker, sorry, that an attacker could use to bypass your security control or not? And so is it capable to do something because there is a fancy route and can bypass your load balancer and go straight to it through a router or something, your pool? That is the biggest conversation that you should have. When I did all material on how to do an infrastructure gap analysis, I gave you that analysis layer by layer to understand which security control are overlapping in function. Because if you have a device, doesn't mean that it's fully configured to do whatever. If here you are having a firewall at layer 7, for example, what is capable to do at layer 7 is the next question that you should have. Is it capable to actually take action, see something, even if it's a payload within an SSL stream? It would mean that it is terminating the SSL. So what I'm trying to do with these courses is to give you the way of thinking. I don't want to overcomplicate things because they are quite straightforward and simple. But when you look at network diagram, they don't tell you how it's configured. So it's a bit of the same story when you look at an X-ray. You see the picture that is static. You didn't move. You don't know that bone, how change, the joint, how is moving, because it is nothing done to picture that. Here is the same stuff in infrastructure. You need to have the thinking to question the diagram that you are evaluating, understanding the correlation with the configuration, and understand, for example, that how a push, a change of configuration of that device can impact your attack surface. If there is an issue with an orchestration, an internal threat, a disgruntled employee is pushing a configuration, you should have control in place to be 100% sure that is not changing that attack surface because, for example, you block that push of a configuration. I hope this one is clear. As I state in our summary here, uh, inspection design, not always a solution. It's not always a solution because when you come here, if you want to break the SSL, you need the certificates. You need to be sure that you don't create a point where an attacker can go and intercept credit card numbers, for example. You need to understand also how is tricky any change of configuration and any tapping point. Uh, it's good to have a tap, network tap in the meaning to be capable in an incident to sniff data, but you need also to understand what it does mean security-wise. If it get compromised, if it get enabled when it shouldn't, there are tons of situations that can give you a big impact. For example, if you have a tap in cloud, it can be orchestrated through an API. So you need to be also aware that an API call can enable stuff. Because somebody wants to sniff your credit card numbers, could use that. And you should have the security monitoring to see that. So most of the conversation in security monitoring are about the UML flow of all devices where it's passing through the load balancer, the pool, but there is an underneath infrastructure in cloud, for example, that is all API exposure. So if that change, keep it in mind, think about it. Okay? So the next lesson we talk more specifically about TAP. I will discuss about VPC and how tricky it is the attack surface also on the VPC. Don't think that this conversation is not cloud related, because if you have an infrastructure as a service, what you see here as the BGP router would be your VPC at the end of the day. And the load balancer here will be an ALB, for example. Even if it's not another spinned image, it's just another service on top of that. You could have a service group in terms of firewall straight into the VPC. You could have reverse proxy capabilities and policy somewhere, but the thinking doesn't change. Design, inline, not inline, configuration, what you can see. SSL, can you actually see everything? Because if a connection pass through, it doesn't mean that you actually have control of what it does contain, for example, tunneling. And do you have any control that it does have a fail to wire, even virtually in an environment where it can fail open? And the fail open security wise is a big conversation. Can your control be bypass, change as a configuration? Can the management access compromise your entire infrastructure and attack surface? That's are the question that I want you to have in mind when you are analyzing network diagrams. The network diagrams, even in cloud, are a bit funny because you never see all API management underneath. Check it out, all fancy diagram. It's unbelievable. The design is for sure getting way better. A bit of a challenge to remember all icons of all new service, considering that every 3 days is starting a new service. But it doesn't contain those. And you, as a security architect, as infrastructure security consultant, as a CISO, as a whatever you are, you should think of it. And you should think also from a forensics standing point. Accountability is not only logs, is also know that you have artifact that can be analyzed. So never forget forensic side of a conversation. The industry is doing that. You shouldn't. Okay? Thanks a lot for listening. I hope you enjoyed. Uh, Post me a comment. Tell me what you think. I would like to hear your feedback as well, time to time. If I can help you on something, I'm here. Drop a message. Okay? Take it easy. Cheers.